All right, so we are going to start a new topic called scientific notation. You might be wondering, what is scientific notation? It's just an easier way to write larger numbers. Okay, so it's just an easier way to write larger numbers. It's written like this, where C is a number between 1 and 10. So that's super important, that C is a number between 1 and 10. And N is some number, right? Because it's the exponent. Okay, so some steps from converting from standard, so regular numbers like 1 billion to scientific notation. Okay, first thing you do is to find where the decimal point is or would be written. Okay, and then you have to move the decimal point to the right or left to make your number greater than or equal to 1, but less than 10. Okay. So this will make more sense in a couple minutes when we do an example. And then if you moved the decimal point to the left, then the exponent is positive. If you moved the decimal point to the right, then the exponent is negative. Okay, so if you need to pause and get all those notes, that's okay, pause right now, otherwise I'm going to keep on going. So what that means is first we have to find where the decimal point is, right? So looking at a whole number, 2000, imply decimal point at the end. And we want to value between 1 and 10. So look at numbers between 1 and 10. So it's going to be 2. First, our decimal place includes the number 2. So we want 2 times 10 is a power. How many times is that? We get 1 by 30 times. It's going to be 10 to the 3rd. Okay, so look at G, we are already given our decimal place, and we want to get it between 1 and 10. What's the number between 1 and 10 here, or the first number between 1 and 10 is 7, right? And we're moving it to the left once, twice. Since we move it to the left, we're moving to the right. We're moving it to the right, and then once, twice. So remember, this is going to be negative. 7.69 times 10, we move the times to negative. Okay, so looking at B one more time with you, we put an implied decimal here. We want to fit, so we see a C value between 1 and 10. We want to move it to the first 4. We move it 1, 2, 3, 4 times. We're going to write a number 0.4, 2, 6, 8, and then to the left, and we positive 4. Positive. This one, again, between 1 and 10, it's going to be the 9. We want to move it 1, 2, 3, 4 times, maybe to the right, so it's negative. We have 9.1 times 10 to the negative 4. Alright, so I want you to pause the video, and I want you to C and B right now on your own. C and F on your own. If you didn't get 2.6 times 10 to the 2, it's not like 36, because remember the C value needs to be between 1 and 10. And the second one should be 5.84 times 10 again to the negative 3, because we went to the right. Okay, so let's keep on going here. Let's talk about converting from scientific to standard. Okay, so all we have to do is to move the decimal, the direction, and number of the power of 10, aka the exponent. Okay, so we move the decimal, the direction, and number of 10. So if it's a positive exponent, we move to the right. So the opposite of what we do up there. If it's a negative exponent, we move to the left, however many. Okay, so again, if you need to jot that down, pause it. Okay, but otherwise, I'm just gonna get started. Okay, so look at a positive 2, right? That tells me if it's positive, I go to the right, so I'm going this way. There's an implied dot here, and I move it once, twice. If there's no numbers, we plug in 0. So this should be 300 then. Remember, there's an implied decimal here. A negative number means we go to the left. We move it left 3 times. 1, 2, 3. There's no numbers, we put zeros. So it's 0.2 zeros and then a 6. All right, so I want you to try B and D on your own right now, okay? So pause the video and try B and D. All right, should have got 24,000 for B and 0.095 for D. All right, the next couple we're gonna do some examples. So I wanna know, are the following in proper scientific notation? If not, convert them. Okay, so that means we have to look at the C value. Remember, it has to be between 1 and 10. Okay, between 1 and 10. Is 25 between 1 and 10? No, right? So we have to move that 1 place to the left. And since we're moving it 1 to the left, we should be adding. Since we moved it once, we have to add 1. So the real scientific notation should be 5.36 times 10 to the 4th now, because we had to add 1. Okay. Let me know, is 900 times 10 to the negative 2 in scientific notation? Hopefully you're thinking no. Here's the decimal. We have to move it once, twice. We moved it to the left, so we move it positive 2. So it becomes 9 times 10. What's negative 2 plus 2? It's going to be 0, aka it's just 9. Okay. So try C. I want you to pause and try C right now. So because we had to move to the right, we had to subtract because we were moving smaller. So then we had a -1, so 4 minus 1 is 3. So it should be 2.36 times 10 to the 3. Last example, we have to put these in order. Okay, we have to put these in order. So we have to put them in order. We want to look at our exponents, right? The bigger the exponent, the bigger the number. So since it's least to greatest, we'd want the really small numbers here. So the smallest exponent is Goodstein Village. I'm just going to write Goodstein. Okay. Then the next smallest is going to be the 4. So that's Gilroy. And then the next smallest, there's a 6. There's 2 6s, one here, one here. So look at the C values. Which one's smaller? 2.5 or 2.4? 2.5, right? So that's going to be the next one. So that's me, Myers. And then Furman. And then that leaves Nave as the biggest. Okay, and we looked at this column because it said 2000 and this said 2000. So I want you to try 2020. This should be 2020, sorry. I want you to try that right now. Try that one for yourself, okay? So pause and try that. Right, so hopefully you got Goodstein because she had the 4, then Gilroy, because if all 3, Gilroy, Nave, and Myers all have 7, but you have to look at the smallest, 1.8 is the smallest, so Gilroy, and then 3's smaller than 4.3, so Nave, and then Myers, and then Furman's had the 5.3 and 8. So that's that.